If you think about Cisco as a company, Cisco wants to grow their business mid-teens. That's what we tell the analysts, right? We want to grow our business annually mid-teens. You know, that was kind of easy to do when we were only doing $1 billion worth of business. I can remember a national sales meeting one time when Cisco was talking about, because we were growing our business mid-40% year over year. You talking about some surprise on your numbers when you got them the next year? Yeah, they were going up 40%. They were taking good accounts away from you, and next thing you know, your number's 40% bigger. But we killed it. We killed it. We were growing our company that big. So guess what? Cisco was doing all that as a small company, but when you get bigger, it's harder to do that. So now we're telling analysts, where are we trying to grow our business? Mid-teens at best, low teens, mid-teens. Well, it's hard to do that when, heck, over 50% of our revenue is in routing and switching, and we dominate those, and the market doesn't grow that fast. We've got, if you've got revenue, let me do revenue and market share here, we're dominant players here. We get great revenue, it's way up here. But how fast can that grow? Sometimes it shrinks. Switches have been shrinking 2% annually. Switch sales. We've been holding our own with that. Overall, switches sales are actually shrinking. So guess what? We can't change our number with that. We have to change our number with the thing that's in here, the advanced technologies. What we used to call the advanced technologies. The thing that's $1 billion business or better for Cisco. So let's just think about wireless LAN. Can we grow our business on wireless LAN? Oh yes. It's a great growing opportunity. But it's probably not going to drive our overall number of over $40 billion, that 10%, 12%, 14% we want to. But it can help. We are 50% of the market, and if the market's growing, we can grow abnormally more than that. We want our unfair share of that. So certainly, we might be able to grow a little bit. Security. Video. All these things are things that are in there that we play really well. It might be a growing market, but overall, we still can't grow our whole number the way the analysts might want us to be to keep our stock price where it's at. So we have to launch new bubbles. We have to get new things out there. The MDS 9500 was a new bubble. It was revenue that we'd never had an opportunity to get until we gave this new product out. With that new product, we launched out Storage Area Networking, SAN. Now, we've invested $60, $70, $80 million in it, and eventually it started growing after we got it out. It started growing to, maybe a $400 million market. After it comes to it, we'll just put it in there and say SAN as a part of our advanced technologies and part of that bubble. We can grow that and everything. This is new money for us, right? Data center switching. And it was in a huge market, a huge fast market, fast growing market, and there was a great demand for it. So we accelerated what we did. So in a matter of, it just seemed like every month we were coming up with something different. Nexus 7000, Nexus 5000, Nexus 2000, Nexus 1000. Not even a switch, it's software. That's bubbles up into here to grow our business because we have to. Eventually we said we need to attack another market. There's another opportunity for us there. There's a different type of server out here. There's a different type of server out in the networks. We have these standalone servers and everything, and virtualization's doing really good. But there's a different type of server out there. This different type of server, and I'm going to turn this way so you folks can see. Can you see this over here? Can you folks see it? The different type of server is a blade server. Because they made a liar out of me. I kept saying a server is a server is a server. It's commoditized. Who cares about servers? I wasn't selling them, so it wasn't putting money in my pocket. I could say anything I want to them about. But Cisco said, now that we're virtualizing, blade servers are a little bit different. The typical blade server chassis had what? It had Well, it had 2 power supplies for redundancy. It had a management module in it to manage the servers inside of there. It had Ethernet connectivity. Cisco actually used to sell catalyst switch ports that would go in that for IBM and HP and Dell and everybody else. It would have HBAs inside of it. And then you would buy server blades that went in there. You could maybe get 1 through 12 server blades in there. The value of this is I could get more servers per rack unit with the blade servers than I could if I bought standalone. That was the benefit of it. Each one of these blades had processing and RAM on it. It used the power supply and Ethernet NIC cards from all these other things. So it was a chassis. That's all it was. The thing about it is when virtualization came in, this thing had some holes in it too. You had the processing, so now I start getting 4 cores here and 4 cores here. I'm running one application on it, it's only running 10 or 15% utilization. I want to run VMware on it. So guess what? I take a couple of cores, run one application on it. The problem is this thing only had 96 gigabyte of RAM available on it because of the way they'd been building these things over and over. Been enough for just one application, 96 gig is plenty. But if I'm running multiple applications on it, that goes away quick. Let's say my first application needs 48, my second application needs 24, my third application needs 32. Uh-oh, I'm already out. Even with simple math, that's wrong. Cisco said this is an opportunity for us to go back to 0 and build a blade server like it was built for virtualization, and that's what we did. That's where the B series chassis. Why did Cisco do this? Blade servers were a $37 billion market opportunity. New money that Cisco had never had a chance to get. We needed a new bubble, the UCS bubble. If we could just in a couple of years get 10% of that market, how much new money is that into Cisco? $3.7 billion of new money. Could we use that to grow our business? That's a significant amount. Does this make sense? This is why Cisco does all this stuff, man. We've got to get new money. We've got to find some place where we can, if we can't grow the markets, we'll enter new ones where we can make a difference. And this is a place where we could make a difference because we had a way of doing it. So let's look and see what we did with the B series.
Andy, is that R&D here in San Jose or everywhere?
Yeah, we incubate more on this campus than anybody ever knows. Most of the incubation is there here, yes. Not to say all of it is, but most of it is. So let's just think about this. Cisco said, let's think about, we need a lot of RAM. We need a lot of RAM in our blades. We're going to have, we'd like to think about it, one management point for 12 servers. If we could do better than that, that'd be cool too. So our requirements to differentiate ourselves in this market came out. So what Cisco came out with was kind of a lot different. A big chassis, a big solid metal chassis, the 5108 chassis. It's just a big metal housing with connectors in it. Inside of that, we're going to put the ability to have 8 half-wide servers in here. So this is where our servers will go into. That's why they call it a 5108, because there's 8 slots here, maximum of 8 servers. We're going to put some, power supplies in this thing, in there. And this is just bare metal. Our smarts that we want to use, we're going to actually put them outside of this box. We're actually going to have 2 boxes on top here called fabric interconnects. The fabric interconnects have our management platform. It's got our management platform in there. And we'll talk a little bit more about that in a second. But that's what we're going to do. We're going to have, it's going to be a little different than what traditionally was out there. So I can put my server inside of here. Now on the back side of this, I'll do it in like this. We're going to have connections from here to there. We're going to have 10 gigabit connections. We're going to have the ability to have 8 10 gigabit connections. Small b, Eddie. 8 10 gigabit connections up here. So we'll take the possibility of 8, 10 here, 8 up to this guy. So I'm going to have the ability to have 160 gigabyte of connectivity in and out of this one chassis. Out of this one chassis. And inside of each one of these connectors here is going to be Ethernet that will go out this way to the user. So the user can get in and out, and it's going to have fiber channel over Ethernet that will come up and go out to the storage area network. So we're going to have unified cabling. One cable is going to carry all of that stuff for our servers. Yes?
Can the ports in the fabric interconnect directly connect to the controller on the server?
Yes, absolutely. Yeah, you can actually do fiber channel straight out of there. Yep. Yeah. Does this make sense? This is what Cisco came up with. And the cool part of this is so when you buy it, you buy your servers here. Now again, the problem with these servers, these blade servers, ended up being the memory issue. So Cisco went to Intel and said, hey, listen, we can build some ASICs here. And we got some ideas about this. Typical memory into a processor, let me do this in green. So if you've got a processor here, it's going to be able to see memory coming, RAM memory coming in these DIMMs, right? It's memory you put in there. And it can only see 4 of those, which is limiting us over there. Cisco said, can I cheat this and will you support it? And they said, cheat this? How do you mean? What I want to do is I want to build an ASIC here that makes this guy see 4 DIMMs, but I want to put 4 times that on here. I want to be able to represent 384 gigabytes of RAM back into your processors if I build this chip. Intel said, that's kind of cool. And we'll support it. This is called extended memory technology. And it's the first thing that we did, kind of cool, to get our name out there. It's the very first thing that we did. What does this mean? It means you could virtualize more applications on our blades that required a lot of memory than anybody else at the time. Now, it was a short-term win, but it got our name out there and customers started looking at this. At least they were considering us. At least they were considering us. But we had other benefits that I think are even more attractive. Remember I told you that we've been working with VMware. We were actually part owners of VMware. And we've been in there looking in their labs at things they were doing. And Cisco said, you know what? There's some really cool things that you'd like to do VMware. Did you know VMware used to be is in the switching business, even before they acquired this other company? They actually, if you think about it, if I run multiple servers on here, I'm going to have multiple NIC cards, multiple VLANs, all this, that, and the other. So VMware figured out that they needed a software switch on their hypervisor software in order to be able to do that, to do all the QoS and things like that. Well, when Cisco went in there and said, what are you guys doing? And they said, we're trying to work out this software switch thing and we're not really good at it. Cisco looked at him and said, why don't you let me take care of that? I'll do that for you. I'm good at switching. I know how to do that. So Cisco actually came up with software called the 1000V, the Nexus 1000V, which is a software switch that does all of that for you. Matter of fact, if you buy the Enterprise, the large highest end, it comes in all the VMware inside of that. Why? So we can do QoS on these multiple machines. We can do all kinds of cool things that I'll show you in there. Our core competency was switching. Even in software, we could do it better than VMware could because that's not their core competency. So Cisco actually created the 1000V software switch. They also said, our interface here, our management's not going to just manage one of these chassis. It can manage more. So if a customer buys one chassis, these fabric interconnects, and wants to expand and have more, they buy another chassis here, a 5108 chassis. They put the servers inside of it, and then they run that up here to these guys. What if one management point for 20 of these chassis? For 20 of these chassis, 20 times 8, that's 160. You can manage 160 servers instead of 12 at one management interface. That's what Cisco did. Customers like that too. Less management interfaces, easier to manage and all that. We also found out, and I'm sure it was hard for Cisco to do this, to say, when we design our management, we can't be the lead. You know, when you go dancing, I'm not a very good dancer. But you know what? I've learned enough. Two people can't lead when you're on a dance floor. You step on each other's toes and it looks pretty stupid when you're out there, by the way. Guess what? We know that VMware is going to be the lead in the data center because they know what's going on with the application. They actually know the performance of the application, all the important stuff about the application. So we're going to design our management to be subservient to VMware, but give them a lot of information. And by the way, we'd like to make it to where instead of having all these management points, you could use our managements for servers and actually make a server profile inside of our management that has 3 distinct values. I'll have my IT organization put all the MAC addresses and VLAN information, all the networking stuff in this software. And then somebody from the storage, the SAN group can come in and the same software, the same application can put their information in. And then the application guys can come in here and tell us all about their application characteristics. We can put everything that used to, it's like 61 different characteristics, 61 or 62 characteristics that used to take 3 separate management platforms to find out everything about in one. We can make something called a server profile that is one pane of glass that has everything about that server that we need to be able to move it anywhere we want to. And customers love that. What's that mean? That means within 20 of these chassis, if I have a virtual machine running right there, I can move it anywhere on any of these other 20 chassis in the same management plane anytime I want, any way I want. Just like that. And who tells us to do it? Not Cisco. VMware does. We let VMware tell us where to move. They say, it might be a time of day thing. From 12 o'clock at night till 6 in the morning, we're running our application on 2 core processors and 24 gig of RAM. But guess what? 8 o'clock in the morning or 6 o'clock in the morning, so a lot of people start coming in. My utilization goes up, my application says, I need more help. We can move it over here into this because we've got 8 cores and 64 gig of RAM. The same, bang, put it there. Do you think customers would like that? Yes, sir.
How is that unique to Cisco?
How's that unique to Cisco? It was designed to do this. Customers love this. This is still unique to Cisco. This is still unique to Cisco, this management interface.
No, sorry. The ability to move a virtual machine anywhere in your
Oh, that's a
server
VM.
environment.
That's what VMware does, but it's how easy it is to manage this in this management plane of ours. Totally unique.
But we could do it on a physical level also, with the service profiles.
Yeah.
If we were to upgrade a 2 CPU machine, which has got an X service profile, and it is supposed to, let's say it's running an running as an SAP production service, it needs more computing capacity.
Yeah.
On a from a 2 CPU machine, you can move the service profile to a 4 CPU machine seamlessly, which typically takes about hours or days.
Yeah.
To be configured.
In a traditional world, it might take hours and days to move this. We can do it in a matter of seconds. A matter of seconds. Yes. I mean,
I guess I've missed the point about what's different about the Cisco offering.
Well, I think if maybe I can add something.
Yeah.
That might, just want to validate.
yeah.
It's true that you can take the server profile and apply it to a slot, not just to a server. So
Right, yeah.
You can set a slot to have that particular profile, and then once you buy the server, you just plug it in, it will inherit what the slot
But
has.
you can do that with HP today. You can do that with HP for.
Yeah, it's been doing it for a long time. HP has been doing it for a long time. IBM did it for a long
IBM too,
time.
yeah.
Virtual connect.
I'm just trying to understand the differentiator here, right? Because, if we're telling people for the first time they're seeing this, we make sure we start to call out the things that.
Yeah,
why
I
we're
think
better.
one of the differentiators is you have one pane
Yeah,
of
okay,
glass to
that-
manage all
that's-
of this,
That's great.
instead of having one per chassis that HP would have. So that would be kind of the major differentiator.
Correct.
I think scalability is another one in terms of how much VMs you can support on a certain
Yeah.
server.
Guys, one adds, if you see that here is a 3 characteristics that as you drew it, and what's the differentiator, maybe you add to this, that then you move the virtual machine, there is not new, yeah, as VMware can do it before, but when you move it, you change the characteristics of networking and the storage area network, so you do not need to, if you just move it with HP,
Yeah.
yeah, to the new hardware, you've got a new MAC address and new vSAN address. Because physically, those adapters are different. So you should...
Now we can reprogram it.
So
Yeah.
those 3 elements all come with it.
Yeah.
All 3 elements go at the same time. So your MAC addresses are still the same. Your IP addresses are still the same. Everything's exactly the same.
Everything. So
Yeah.
it's much easier. HP can do this right now.
No, but IBM's doing it, and they do virtual MAC addresses, and they have a whole table, and you can do it across a set of chassis. It may have been new when Cisco bought it.
Well, that's what I'm saying. Again, we're driving this, but we drove them to do this, right? And again, it took somebody from the outside going in. So if I was talking to a customer about this, I'd say, well, guess what? Cisco saw innovation here, innovation that wasn't happening with your traditional vendors, because they were certainly happy to just recycle the servers over and over and over. Who wouldn't be? Who wouldn't be? But Cisco came in and said, we had, why? And it goes back to the same thing with IP telephony. Nortel and Avaya had an opportunity to do IP telephony before Cisco did. Why didn't they do it? Before any of this happened, why didn't they do it? They didn't eat their own young. And when they, it was a cash cow. Yeah, if they wanted to do a change, they had to drag a whole bunch of already installed stuff. Why did Cisco do IP telephony? They said if you started this and wanted to do it as an application in 1999, if you could wipe the slate clean and start it, well, how would you deploy it? Exactly like Cisco did. That's the exact same thing we did there. Because the design of the HP and IBM and all those servers up to that point, they had been designed for this and the traditional this. When VMware came, it changed the game. Cisco was clean. They had a clean slate. It's easier to draw a pretty picture on, hang on a second, on this piece of paper than on this piece of paper. Right?
The benefit here is that Cisco is a better innovator, or that it's above the market today?
I'm saying this, Cisco innovated in a place where it would be a lot more difficult for HP to
I
innovate.
get that, but
Yeah.
that's history, and that we did that.
Yes.
What we're about today
Well-
Is this, because if I said to someone, Cisco did this or Cisco did that, they go, so what?
Well,
What do you do for me now?
first of all, and I'll show you where we're doing that. I'm not finished yet.
Oh, okay, all right.
I'm not finished yet. But I've got to show you what were the innovations in order. I can't show them all to you at once, right? But we all agree that extended memory technology for about 6 to 8 months when nobody else had it. Do we all agree that on a single blade, Cisco was the only person to give you 4 sockets on a blade server that nobody else could? Nobody else could do that. 4 sockets, no. All these were 2. Cisco could give you 4. Yeah. And again, I'm not saying they didn't catch up or change and everything, but did they lead the way? Who do you, Mr. Customer, want to go with? Somebody who's sitting there happy to just take your money, or somebody who will enter the market and innovate it for you? That's the conversation I would have with historical value of this. That's what I would say. But Cisco entered this market. And why did Cisco do it? Again, we did it for our own good, our own new bubble. But we came into a market that was ripe for innovation. Ripe for innovation. So again, all of this stuff worked really well and we start doing it. And again, I think our server profiles are still a very, very valuable asset because you move everything everywhere. It's one pane of glass to put everything in. And it's designed specifically to be subservient with VMware and all this, that, and the other. Yes, it gives us a very, very good story. But we want to do more. Cisco wants to do more. Remember that Nexus? Those Nexus switches and stuff? Again, let's go back to the network. It's where we're best at, in theory. If customers were wanting to do that and had multiple data centers in places, maybe we wanted to start consolidating data centers or actually using data centers. Think about it. If I've got a data center over here, a server running an application in this side, in this data center, and let's say this data center is in LA, and I had another data center in Phoenix, Arizona, out in the desert. Nice place to be, actually. And I had some hardware here. Would it be easy to move that same, let's say its IP address is 10.10.10.6. Would it be easy to move 10.10.10.6 all the way across and make it pop out over here? Absolutely not. Think about my... And by the way, there's another server setting right beside of it that's 10.10.10.7 running the same application. And they have to talk to each other on the same subnet. Woo! When this server starts grabbing some database, he actually sends a broadcast out and says, I'm grabbing this database. So they know how to share that database so it stays valid. Wow, that was a challenge. But Cisco wanted to accept that challenge and do that. So what Cisco did, we would connect these guys up, and we'll talk more about, into the 2Ks. We created a fan-out switch called a 2K. It answers to the 5K, which answers to a 7K switch. And what we did is they created a whole new technology, a whole new way of doing things called OTV. Overlay Transport Virtualization, to where you can actually move that server all the way over here with this same IP address. And when he sends a broadcast to that server over there in a totally different area, we will encapsulate it and know where it's at and release it over here so this guy still thinks it's over here. We can take 16 data centers and make them look like one this way. Do you think that customers would like that? That means that you're not only saying I can move a server in any of this architecture infrastructure here, limited to only 20 of these chassis, but now I'm saying I could put it in any of 16 data centers and move it over here and still have them work. Yes?
VMware is going to be coming out with a feature where they'll be able to move a virtual machine across data centers. They'll be coming out in the next release. Okay, so we are a generation ahead of even every year in doing this.
Eddie, what happens to the application's data?
Well, it's going to be replicated in both places, right? It's going to be replicated in both places. That's what EMC and all those guys do. You're going to have an array here, and you're going to have an array here, and it's the software that will make the data work.
So let's say you've got the data in both places and you move the machine from one physical server to a physical server in a different data center.
Mm-hmm.
How do you tell the operating system instance that you're now using the other storage array, which won't look the same?
We could actually
Obviously,
move
have
we could
data.
actually use the same storage over here if we wanted to.
Well,
Yeah, probably wouldn't. You'd probably want to do it here.
yeah, that's what I was
But it's the software with the server vendors that deal with that. It's not Cisco that does. I don't know the deep parts of it, so that'd be a good question for your PSS.
Okay.
Yeah. I'm about as deep as I'll go right there. Does this make sense?
Is there restrictions on distance on that?
Oh, there certainly would be delay and distance and all this. This is going to have to be high-speed fiber optic connections and all this, that, and the other. But
What's the use case for this functionality? Why would customers want to do it?
why would customers want to do it? Let me give you an example. Hurricane Sandy hits New Jersey. How would you like to have your data center in the middle of the country instead of on the coast where it gets destroyed? How fast could I get it there? Really quick. Same IP addresses, same everything.
That's what the thought
Right.
in mind.
And guess what? I could start doing this. I could say, well, I don't know if Sandy's really going to hit us. Let me just move half of my servers over there and wait and see. I can move half of my servers there, wait and see. And then when it does happen, I can move the other servers out. Because I might have to actually, if I don't have 100% of the server utilization here that I need or server capacity I need, I move half of it here. And then I have to start prioritizing which server blade do I use for what application. But at least it gives you what you need.
So I figured that might have been the use case. So that's why I asked the question about
Yeah.
storage. 'Cause
It's making 16, and I don't know how they do that in the back end. I really don't. And again, I'm not a PSS with that.
Makes management also very simple. Let's say, let's say take an example, an organization has got multiple data centers and a single administrator wants to see what's happening in the other data center, whether the utilization is proper there or not. In case he finds that the utilization of the resources is not up to the mark, he can seamlessly move the machines here. So from a management perspective, this kind of gives a lot of flexibility to the administrators.
Yeah, absolutely. I mean, it takes away limitations. And I know that people are using this. I don't know exactly what you're doing down there. So you'll have PSSs who can tell you everything about that. I've gone to my limit of my expertise here. And man's got to know his limitations. Clint Eastwood said that. So, does this make sense? Cisco has done this in a very, very, very short period of time. Think about it. When did we introduce servers? Yeah, 2009. Wow. 2009 we did this. In a very short period of time, has Cisco been an innovator here? Whoa, we've been leading the pack. Yes, sir.
So it was just announced that UCS is the number one in Australia.
It is? It's number 2 in North America.
Yeah.
So it is number 1 in Australia.
In fact, if you do, I was attending one Zcast. If you do this simple mathematics, the number of customers that we have acquired is some 17,000 customers. Over a period of 3 years, it works out to be 21 customers a day. So
How many?
21 customers. a day.
21 customers a day buy our stuff. Wow. 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 So all in all, the Cisco infrastructure and the architecture that Cisco is starting to put in place here, again, has evolved pretty quickly, to be honest with you, in a very, very short period of time. Cisco's put a lot of money where their mouth is in R&D and acquisition and this, that, and the other. So in essence, we've got the B series chassis. We have the C series servers. What's a C series server? Does anybody know the C series? It's a standalone server, right? Again, built for virtualization and everything. But again, it's got its own power supplies. And again, it can have a lot of different cores and all this, that, and the other, but it's really a standalone solution. Now, can it be managed from that fabric interconnect? Yes, absolutely can. So you could actually manage you could manage your standalone servers with virtualization as well as your blade servers all in one interface, which is I think it's something different as well that Cisco does. Again, so we have these different servers. So let's look at kind of start from the ground up and work with some of the things that we're going to have in this. And I'm going to try to draw this on the fly. Boy, are we all in for an experience. So we're going to have our servers. We're going to have blade servers in racks here with our fabric interconnects. Our fabric interconnects here. We'll have multiple racks of blade servers, these guys fitting in to these fabric interconnects like this. Like that. So we're going to have racks of servers and using the fabric interconnects to manage up to 20 of these chassis, each one of these having up to 8 servers in it. So a lot of servers, a lot of density there. For our rack-mounted servers, whether they're traditional servers or other servers, we're going to have to connect these guys. Now I'm going to put these some top of rack. We're going to have to connect those in and out. We're going to have the fabric interconnects, or the fabric interconnectors here, the 2200 series. Now, what they are is fan-out. Remember we talked about chassis-based switches like this? Remember I said you have to have a supervisor, which is the brains, and then you have all these line cards? So you've got the supervisor and the line cards. Well, Cisco has actually had to create some virtual chassis inside of the network to be able to deliver all of these ports that we want. So what we do is on these racks, we're going to put the 2200 series fabric interconnects on the top, not fabric FEXs. They're the fabric interconnects. Yeah, the fabric interconnects in here. So they're the 2200 series of fabric interconnects. They're actually the blades. So these guys will connect multiple servers and all this. We can put them in, if these are standalone servers, we can have them here. Let's say I have standalone servers, somebody else's servers, whoever they are. Our servers, rack-mounted servers, whatever. We'll put some 2200s up here, depending on what they need. All of these are top-of-rack switches. They look like top-of-rack switches. They're actually blades that need a supervisor. So you'll have, several rows of these servers in here. And you'll have these top-of-rack switches, the 2200s, and they all will fit to the end of row. And the supervisor for all of these 2200s will be the 5500. It's the supervisor. So you actually have a virtual switch with blades out here. So these guys will all be interconnected to these guys. Like that. These are the brains. This is actually where all the smarts are. These just are pass-through. They just are pass-through. There's an actual standard coming out for all the tagging that they have in here for this. I think it's B something.
Is your limit to how many you can stack on that?
I think the limit today is 16. Is it 16? 16 on this. Yeah, and on the 5500. For the 7000, these can also answer to a bigger switch, the 7000, and I think they can do 20 or 24 on a 7000, a blade on a 7000. Yeah. But in essence, what does this give us? It gives us more connectivity, and all the intelligence is here. So our lower cost, this is where the smarts are. This is where the smarts are. So think about it. We're bringing all of this, all this unified fabric, all the Ethernet, all the fiber channel over Ethernet, all the way back to this guy, and now this guy can actually feed it back out. He can take fiber channel protocol and send it over to an MDS and actually into the SAN proper, if you wanted to, right? You can have the Nexus 7K up here, which will, these guys will connect into the Nexus 7K. 40 gig Ethernet, whatever you want to put there. These guys will support 40 gig Ethernet back into here. So you could have several of these blocks of this over and over and over. You're cookie cutting the way you would design it, having this one module here, this one module here, this one module here. So the top of rack, end of row kind of solution that you have. These 2200s are not smart. They're not smart. And you can get those to support 100 megabit, gigabit, or 10 gigabit Ethernet, depending on which flavor that you have Ethernet coming out of your servers. Yes, sir?
Sorry, when you got fabric interconnect with your blade,
Uh-huh.
do you still need a fabric extender in that?
Well, the fabric, that's what that is, a fabric extender. That's what this is, fabric extender. That's what it's called. FEX, fabric
So
extender.
you're only using 2200s?
Right, 2200s back into the 5K. Does that make sense?
But is the fabric interconnect?
The fabric interconnect can either go directly into one of these or back into this guy itself.
Okay.
Yeah.
So you would still
Yeah.
potentially have fabric extenders as well as...
Yes, absolutely. Yeah. Depends on, you could have, and again, I won't do the design, every design might be different, but if I have racks of servers here, the standalone servers and everything, I'm probably just going to have the 2200, unless somebody still wants to use a SAN, traditional SAN and fiber channel, then I would have some fiber channel switches in here as well, and I'd only be dealing with Ethernet. I wouldn't be doing, unified fabric. Does that make sense? So there's a lot, again, there's a lot of different ways. There's no one data center. It looks like every other data center. Yes?
So with the technology going from 1 gig to 10 gig, how soon do we see 100 gig being a reality?
It's actually shipping now.
Right,
Yeah. 40 gig is shipping in here.
right.
40 gig and 100 gigs on its way.
It's right on its way.
Yes,
Right.
absolutely.
Okay.
The Nexus 7K is already ready for it. The 5K, the new 5500s are 100 gig ready.
I just wanted to make that
Yeah.
clarification.
Absolutely. Absolutely. I mean, I don't know where it'll end. I don't know where it'll end, but it'll be faster than 100 gig, I guess, because I've lived to see that. Yeah. So that's kind of how this solution would work. Now, Cisco's made some relationships. They've tore down some relationships. What do you think, HP and IBM thought about Cisco when they started selling servers? Boy, did that sour a relationship. Absolutely. Cost Cisco a lot. Again, Cisco entered they've got this triangle of support now, this love-hate relationship with EMC and VMware. We've created these, the V-block. I'll show you the V-block and what the V-block looks like. The V-block, they created this organization called VCE, which is VMware, Cisco, and EMC all together, where they actually can sell you one solution. It's a box that's got EMC software, EMC hardware and software for storage. It's got VMware for the virtualization of the servers and Cisco's servers and switching capabilities. All in one, in essence, part number. It's called a V-block, and I'll show it to you online when we get to the product section. We've also got a connection with NetApp. It's called FlexPod, and in essence, the storage is FlexPod, VMware, and Cisco infrastructure for that. And again, what we're selling with all this stuff, and I've been dying to get into the subject, is what we're selling with that one product number is a cloud. We're selling, virtualization has led to the real use of the cloud. For our service providers. Think about service providers. If we were just doing standalone servers, would a service provider be able to do application support for customers? Think about all the servers they'd have to have and all this, that, and the other, the different operating systems. if we were just doing standalone service, it'd be impossible for a service provider to actually think about offering a cloud solution. But when you've got this technology now with this virtualization to be able to maximize the use of your resources, and again, if we think about service providers, they want to sell the same thing over and over. And now they can. They can sell the same physical server over and over and use it over and over with virtualization. So it's led to the cloud, the opportunity that the cloud is. It really has. So from a service provider, it's helped them out to actually start developing a whole new revenue stream. A whole new revenue stream of offering services, hosting services for customers that they probably couldn't. Oh, them doing it as well. Absolutely. It's not only your service provider's name, it might be a lot different than you ever thought. Yeah. When we talk about HCS tomorrow, hosted collaboration solution, the providers for that are 90% of them are non-traditional service providers. They're not the AT&Ts, IBMs, British Telecom, all this of the world. It's the other partners who are doing it. And they're doing a very good job of it. They're doing a very good job in a lot of places. And it's a whole new revenue stream for them.
And in fact, one of the biggest things about that in terms of mindset is actually what's winning that is the relationship, not the technology.
Oh, absolutely. Absolutely. It is the relationship. Yeah, exactly. The barriers to entry to that market have came down. Used to be, if you wanted to host voice, you had to have a big class 5 switch and all this infrastructure and all this. You don't have to have that all anymore. We're talking about servers and applications here. So this virtualization and all the things that we've came up with are certainly, Cisco's helped develop here. And I think Cisco's had an instrumental role in this. They didn't do it all themselves, but they certainly took full advantage of it. Has led to a lot of money coming into Cisco, that new bubble. Really nice for Cisco. And it has soured relationships. Some relationships have healed back a little. Some relationships are still going to be not as happy as it used to be. I personally, I don't know what the numbers showed out because IBM and HP used to resell a lot of Cisco stuff. And boy, you don't think they don't want to sell anything Cisco now. And vice versa. Cisco would never, it's caused a lot of grief in the industry as far as it goes with that. And some customers have actually mentioned it to me. God, I wish this Cisco, HP, and IBM thing would quit. Well, everybody's got to do their own business. Everybody's got to do their own business. So that's the data center in particular. And again, these 7Ks, the 7Ks, they have an outward facing and an inward facing. We actually have two different series of cards that go in these things. You have F cards down here in the bottom that go here. So when you look at a 7K, at the cards that go in it, you'll have modules that go in here that start with an F. They point downward. That's their job. You'll have M cards. M cards point out. They do routing tables and all this, that, and the other. So there will be different cards that go in these, and I'll show you that online when we get into the products. So Cisco's got a lot of things. Yes, sir?
Are many people using the Nexus, 5 and 7Ks without going to the UCS compute, or normally is it all together?
Yeah, yes. There's that's a religious war, right? This is not so much a religion. This is a really good use case for this. When you get into servers, you enter a different layer of religious war. So and again, for our collaboration solutions, if you think about it, we're selling a lot of servers there. When we have UC on UCS, right, on our B series. That'd be great. But our collaboration specialists are not going to fight this war for our data center people. They'll say put it on a C series. Customers are much more familiar with putting it on a C series, a rack-mounted server, and it doesn't fight that religious war. So yes, sir.
Why did we have to introduce a new operating system with these switches?
With the switches, the Nexus OS? All right, so first of all, it's not a new operating system. All right, so this operating system has been around since 2002. It was the same operating system that was on the MDS 9500 that was released in December of 2002 and became the #1 director class fiber channel switch in the world. It's the same operating system. It's different than iOS. Now, why did we have to do it? iOS has been around for a long time. This is a Linux core with our iOS on top of it. That's all it is. What does it allow us to do? It allows us to give not only hardware redundancy, but software redundancy. Because what we can do is we can start isolating things that we do in services, software services, and if these individual services lock up. So let's say that I have a Nexus 7K up here. Part of the services they'll be running up here might be BGP, a service of BGP. If that service starts here, do I want it to stop all my traffic that's going in here? Maybe not. So putting a Linux core on this allows me to do software and hardware resiliency, so I can have a software restart this service in the Linux box. And if that doesn't work, I can always use this hardware of another interface, another card. So it actually gives us two types of redundancy. It gives us the ability to add other services on top of it, which iOS was designed back in the mid-90s, and it was closed, and we couldn't add any other services. So now we could actually put other people's applications in conjunction with ours and work very well. So it's really opening it up.
So iOS isn't based on Linux or anything?
No, old iOS is not based on Linux. No, it's not at all. But all the new stuff is, the new Catalyst 6500 and the new 4500s, all running on Linux core, running a Linux core.
So they're not running iOS,
They're running iOS on a Linux server, inside of a Linux server. We've ported iOS, the capabilities of iOS, to run on a Linux-based server.
But
Nexus is the same thing.
That's the same.
Yeah, absolutely. The last thing that goes in this, I can use every iOS command. Matter of fact, when I saw the MDS 9500 for the first time, they looked at me and said, "You're an old switch routing guy." And I said, "Yeah." They said, "Can you sit down here and tell me what commands we missed?" If an iOS guy can configure any of these boxes the exact same way they could do an old router back in the 90s. But now, if we want to have a GUI, it's much easier to have a GUI.
Why is it called something different?
Because it's running a different version of it. They just had to change the name of it. Yeah. So iOS Nexus is the operating system. I can still use all the commands of iOS and do everything I ever want to do. An old router guy like me,
So the
command set's the same. Just the interface is different. So I can have a GUI interface, like people like in a data center. They certainly like GUI instead of command line. Or I could actually do command line. I have the best of both worlds. But the real reason, underlying reason for that, is to put it in a core where individual services don't stop other services. So I could have an operation in Linux, a thread in Linux, that's my BGP tables. And if that starts having issues, I can restart that service in this card, try to restart it here, and if not, go to the next card. So I have multiple redundancies. Restart it here, it doesn't work, go down here. But does that affect any of my other stuff going on over here? No, it doesn't affect it at all. I can compartmentalize. Yeah, it's why don't we use COBOL and BASIC anymore? That's really it. It's the next iteration, and Cisco's moved to it. Yeah. Yes.
As we're having these conversations with customers on like 6500s versus Nexus 7K, and there's a big difference between the two. Like, what do we care if they stay with 6500?
Oh, well, I wouldn't care, but I'll be honest with you. Per port 10 gigabit, Nexus is cheaper than 6500.
Okay. But if 10 gig is not...
If 10 gig's not big to them and everything, then yeah, 6500s. Yeah. Yeah. Absolutely. Does that make sense? I mean, I hope I've addressed the questions and stuff. And again, Cisco just moved on. They had to with the operating system. And they wanted to run it on a Linux because you can use multi-processors now. We can have, this process using this processor using that processor. So kind of much more flexible for us.